Lesson 11.2, surface area of prisms and cylinders. All right, quite a bit of terminology we have to go through to start off. A polyhedron is a three-dimensional figure made up of any number of polygons called faces. Okay, now a blank is a polyhedron. A prism is a polyhedron with two congruent faces called bases, which are located on the top and the bottom, and they are parallel. All right, so that's quite a bit of terminology there. So let's go over to the diagram to the right. All right, now this is a polyhedron. All right, it's made up of a bunch of different shapes stuck together, and you get a three-dimensional figure. And all of these shapes are known as faces, okay, that make up the figure. All right, now what makes it a prism is that it has a top face and a bottom face that are identical. Those are known as the bases, and they're parallel to each other. Now, often when you're looking at a piece of paper and you're looking at a picture, it might be difficult to visualize what this three-dimensional figure actually looks like in real life. So if you're having an issue with that, make sure to look at the three-dimensional figures that are available so you could hold it in your hand and get a clear idea of what we're talking about. The other faces, which are around the prism, are called the lateral faces. All right, lateral, think going around. All right, a prism is named according to the shape of its top and bottom base. All right, so look at this figure that we have here. If it's named according to the shape of its top and bottom base, then what are we going to call it? So this one is called a rectangular prism. All right. And now the blank of a prism is the sum of the areas of all of its faces. That would be the surface area. All right, you're just adding up the area of all of the faces. And the blank of a prism is the sum of the areas of only its lateral faces. That would simply be the lateral area. Okay, now, to determine the surface area of a prism, it is sometimes easier to create a two-dimensional representation of all the faces, which is called a net. All right, this is a very important concept to understand to help you understand the formulas that we'll be using in the near future. All right, so I've taken this figure, all right, and I've unfolded all the pieces that make it. So I've taken it from a three-dimensional figure, and then I've unfolded it, and I've laid it down flat, and I get what's known as a net. All right, so now I could look at all the different faces that make up this figure, and then by figuring out the area of all those faces, I could figure out the total surface area to the figure. All right, so you can easily solve for the surface area of any figure by first determining the area of each face, and then what do? You just add them all up. All right, let's do some examples now. Find the surface area of the prism. Notice that for a rectangular prism, the front face is the same as the back, the right is the same as the left, and the bottom is the same as the top. All right, so here I have the front face. Okay. And the area of that is 8 times 4, which is 32. But how many of those faces do I have? I have 2 of them. All right, then there's the left and the right. This is the right side, this is the left side over here. All right, so what is the height? The height is 8. So I have 5 times 8, which is 40. And then how many of those faces do I have? I have 2 of them. All right, then there's the bottom and the top. I have the bottom, and I have the top. Okay, and the area of the bottom is 4 times 5, which is 20. And how many of those are there? There's 2. So what do all these values add up to together? They add up to 188. And we're talking about area, so it's inches squared. Okay? All right, well, once again, if you wanted, you could create a net of this figure if you so choose. All right, you can lay it down, unfold everything. All right, and find out the area of all the parts that way too. All right, so it's good to be able to see what the figure is constructed of two-dimensionally as well as three-dimensionally. Okay, let me know if you have any questions on this example. All right, for the next example, find the surface area of the prism. This is not a rectangular prism. All right, why not? All right, since there is not parallel bottom and top bases. Okay, so notice that we have a rectangle on the bottom here, but there's no parallel rectangle on the top. Okay, so what do you do then? So you can stand the figure up such that the triangles are parallel. Thus, this is a triangular prism. Okay, so what I'm going to do is I'm going to push this figure upwards so this part becomes the top. So I'm going to flip it over, and it's going to look like this. So this part's going to collapse downward. So I get something like this. All right. All right, that's this rectangle here on the bottom. I just flipped it up vertically. And then I have the top. All right, so I'm going to put that sort of diagonally to give it the three-dimensional feel. All right, see that's a right angle. All right, and do the same thing with the bottom, but I can't see that part. That's your right angle there, though. And then here I have, all right, there's my figure standing up right now. And now the 10 becomes the height. This is 12 here, and this is 5 over here. Okay? All right, now notice that we have a right triangle here. All right, so if that's 5, that's 12, then this is 13. All right? All right, now the bottom and the top. What's the area of the bottom and the top? Well, it's 1/2 the base. The base in this case is 12. And the height is 5. Now I know it looks a little funky because the way in which we drew it, the base and height don't look perpendicular, but because it's three-dimensional, that's why it looks that way. But if you were to be looking straight at it, they would be perpendicular. All right, so now we have times 2 because there's a top and a bottom base, 2 triangles. Then we have the lateral face 1, which is the, we'll highlight this here. I have this face. So this is 5 and this is 10, so it's simply just 5 times 10. Okay, then I have this face here, the back one. All right, so that's 10 times 13. And then I have the front face. I'll use yellow for that. All right, that's going to be 12 times 10. So as you can see, it takes quite a bit of visualizing, all right, to figure out these problems. But the more you do them, the easier it will become. So if I add all these up now, I get what? I get 360. And it's going to be 360 what? Centimeters squared. Done. All right, if you have any questions about this example, please make sure to ask. All right, for example 3, they're asking us to find the lateral area. What does that mean? That means we're not including the area of the bases. All right, just what's around the figure. If all the faces of a prism are squares, then it is called a cube. All right, just be aware of that. All right, so what do we have here? If I want to find the lateral area, I'm going to write area. I'm going to use a little subscript to indicate lateral, little L. All right, and how am I going to figure out the area? Well, I know there's 4 squares, all right, because they all have the same side lengths. So 4 times the area of the square. All right, you're just deriving the formula yourself. So 4 times, what's the area of the square? 6 times 6. So 4 times 36 is 144. That's going to be meters squared. All right, example 4, find the surface area of the cylinder. Leave the answer in terms of pi. A little note here, drawing a net for a cylinder will better help you understand how to find its surface area. Okay, now once again, I have some figures in the classroom that you could hold in your hand to get a good idea of what we're doing here. Let's get a little space here. Okay, so what is this cylinder constructed of? It's constructed with 2 circles. And what is this piece wrapped around it? It's actually a rectangle. All right, if you cut it straight down and you unfold it, you get a rectangle. So this is the net for a cylinder. Looks like this. All right, that's all there is to it. And what do we have here? Here's something else very important to understand. This length is 7. I know that this length is 5, right, because the diameter is 10. Now, what is this length going to be? All right, that's often a question that students get confused about. Now, if this rectangle wraps around the circle, then what must this length be? Once again, it goes around the circle. Well, going around the circle is what? The circumference. So this length is 2 pi r. This length is 2 pi times 5. All right. So now I have all the information I need to figure out all of the areas. So the area for this cylinder is, well, I have 2 circles, so it's 2 times pi r squared, because that's the area of a circle, plus h times, this is the height, right, times what? Times 2 pi r, the circumference of the circle. So there's your formula for the area of a cylinder. All right? That's how you derive it. So you don't necessarily have to memorize any formulas. Often you could just derive them yourself if you really understand how to break down the figure. All right, so let's figure out the area of 2 times pi 5 squared plus 7 times 2 pi times 5. Okay. So I have 25 times 2, 50 pi. Then I have 7 times 2, 14 times 5, 70 pi. All right, so I end up with 120 pi for the surface area of the cylinder. And it's going to be feet squared. Done. All right, on to the last example. Solve for the variable given the surface area of the rectangular prism. All right, they give you the surface area. Now we have to figure out what x is. Okay, how are we going to do this? Well, I know these 2 faces are the same, right? So it's going to be 2 times 4 times 7. All right, then I know that these 2 faces are the same. So that's 2 times 7 times x, right? These 2 faces are the same, front and back. All right, then I have plus 2 times, I have the left and the right. All right, that's going to be 2 times 4 times x. All right, left and right are the same. All right, and that's equal to, they told me it's equal to 298. All right, so you just have to do a little bit of algebra to figure out what x is. 4 times 7 is 28. Then we have 56 plus 14x plus 8x equals 298. 56 plus 22x equals 298. All right, we subtract 56. And we get 22x equals 242. Divide by 22. And I get x is equal to 11. All right, that's all there is to it. We're done. All right, if you have any questions, please make sure to ask. Begin the assignment.